Okay, gang, today we're taking a look at another type of word problem and building equations. In today's lesson, we're looking at coin and stamp word problems. Here's the process. First, list the value of each coin being used vertically. Second, determine which coin should be represented by X and write it next to the correct value. Third, write expressions for each of the other coin values and write them in parentheses next to each value. Fourth, distribute where necessary to get rid of parentheses. And last, write and solve an equation to solve for the number of each type of coin. Okay, so that might sound a little tricky, but I promise you when we get started, you'll understand what I'm expecting you to do. All right, so here's our first example. Make sure you're following along and getting everything that I'm doing on the board. So we have James has $1.45 in change. He has 4 times as many pennies as quarters. How many of each coin does he have? All right, so we have only pennies and quarters. So what I meant by list the values of those is, well, how much is a penny worth and how much is a quarter worth? So we know a penny is 0.01. Make sure whenever you're dealing with a penny that that's what you write. Otherwise, you're going to get the solution for a dime instead of a penny, and then you have the entire thing incorrect. Then we have quarters, which are 25 cents, so we have 0.25. Now we know that he has 4 times as many pennies as quarters. Pennies are being compared to quarters, therefore quarters are going to be X. And he has 4 times that amount in pennies, so that's 4X. Now I have enough to create my equation. So we know it's a total of $1.45 and change. So we have a quarter of X plus a penny times 4X, which would be 0.04X. A penny times 4 is just 4 pennies, equals $1.45. Okay, so now add those together. A quarter and 4 is 29 cents, equals $1.45. And last, divide by 29 cents, and we have our solution. Now, I don't expect you to do that in your head. I'm not going to do it in my head. I'm going to grab my calculator quickly, not my calendar. Whoops, calculator. And we do $1.45 divided by 0.29 equals 5. So X equals 5. So what does that mean? That means that I have 5 quarters. And remember, we had 4 times the amount of quarters in pennies. So 5 times 4 is 20 pennies. We don't apply the value in this case. We just wanted the number of coins. If we applied the value, then our total value would just be that $1.45. 5 quarters is $1.25. 20 pennies is 20 cents. Add that together. We get the 145 we were looking for. Okay, but this is the answer, the 5 and the 20, the number of each coin. All right, so there's one example. Let's take a look at the next. All right, number 2. Madison emptied her piggy bank. She found that she had 84 coins, all nickels and dimes, totaling $7.15. How many of each did she have? So now we know she has only nickels and dimes. Nickels are 5 cents and dimes are 10 cents. All right, so now in this case, it doesn't say explicitly that we're comparing one to the other. All we know that we have is that we have 84 in total. All right, so in this case, we're going to call the smaller value coin the X, and the larger is the number of coins total minus X. So if I have X number of nickels, that means I have 84 minus X dimes. Right? So for example, if I had 20 coins in all and I know 5 of them are quarters, I want to figure out how many of them are not quarters. It would be 20 minus 5, which would be 15 that are not quarters. Same idea here that we're using. So now we have a total of 715. So we can write our equation. It's a nickel X plus a dime times 84 minus X equals 715. So again, I want to distribute A dime times 84 is going to be $8.40 minus, because it's a positive times a negative, 10 cents x equals 7.15. So now we do 5 cents x minus 10 cents x, and I get negative 5 cents x plus 8.40 equals 7.15. Then we're going to subtract 8.40. And we get negative 5 cents x equals 8.40. Let's do it reversed. 8.40 minus 7.15, and then keep the negative. 10 minus 5 is 5, 3 minus 1 is 2, and 8 minus 7 is 1. So it's negative 1 1/4. Divide by that negative 5 cents. A negative divided by a negative is going to result in a positive. And when we're talking number of coins or number of anything, it should not wind up being a negative number. And you can just think of it as 5 cents into $1.25. So how many nickels are there in 125 cents? Well, 5 cents into 1, or it doesn't really work. So I can kind of ignore the decimals. 5 into 12 is 2 with 2 left over. Jonathan, and 5 into 25 is 5. So we would need 25 nickels in order to make that $1.25. And that makes sense because 25 times 5 is 125. Okay, and if you really aren't sure about doing that math mentally, you can of course use a calculator. Please excuse the announcement that just went on. So now I'm going to make sure I can figure out the number of nickels and the number of dimes. So I know I have 25 nickels and 84 minus 25 dimes. So 84 minus 25. 14 minus 5 is 9. 7 minus 2 is 5. So that's 59 dimes. Now, I know at the beginning of the problem I said to assign the smaller value x. It actually might have been easier if we assigned the larger value x, because then we wouldn't have had a negative to deal with right here. But you would get this same answer either way. So you can do whatever your heart desires. Just make sure you're building the equation and working carefully through it so that you can solve for the correct value of x. All right, let's jump to another example. All right, so we're skipping 3. You're going to do that on your own later. Let's go to 4. Alex went to the post office to buy stamps. He bought a total of 25 stamps. Some were 39-cent stamps, and the rest were 23-cent stamps. If he paid a total of $8.47, how many of each type of stamp did he buy? So similar to what we just did, we need to write the value of each stamp. So we know we have some 39-cent stamps and some 23-cent stamps. On top of that, we know he bought 25 stamps in all. So let's make the 39-cent stamps x and the 23-cent stamps 25 minus x. So however many he bought that were 39 or weren't 39 cents stamps were 23-cent stamps. We'd figure that out by subtracting the number of 39-cent stamps from 25. Now we can create our equation. So 0.39x plus 0.23 times 25 minus x equals $8.47. Bringing it down, 0.39x plus, we want to distribute the 23 cents. I don't know 23 cents times 25 in the top of my head, so I'm going to quickly do that. 0.23 times 25 is 575. So that's plus 575 minus 23 cents x equals 847. Now we can combine our like terms. 39 cents x minus 23 cents x is 16 cents x plus 575 equals 847. Subtract 575. So 16 cents times x equals 14 minus 7 is 7. 7 minus 5 is 2. $2.72. Divide by 16 cents. And again, I don't know that math off the top of my head. And the goal here is just to get x. So we do 2.72 divided by 0.16. And we get 17. So X equals 17. Therefore, there are 17 39-cent stamps, and 25 minus 17 is 8 23-cent stamps. So you can see how our coin and stamp problems are very, very similar to each other. All right, let's take a look at one last problem before you're on your own. Okay, number 5. So you're going to try 4 without my help. Number 5, we have Nicole closes her register at the end of the day with $6.60 in nickels, dimes, and quarters. There are 3 times as many nickels as quarters, and the number of dimes is 4 less than the number of nickels. How many of each coin are there? So this is where it gets a little bit more challenging. You have to really pay attention to how each part is worded. So we have nickels, dimes, quarters, 5 cents, 10 cents, and 25 cents. Now, it says there are 3 times as many nickels as quarters. So nickels are being compared to quarters, therefore quarters are X. 3 times X is 3X for nickels. And then it says the number of dimes is 4 less than the number of nickels. Well, if nickels is 3X and it says 4 less than the number of nickels, it would be 3X minus 4. All right, now we can write our equation. We know that total is 660. So that's 5 cents times 3X plus 10 cents times 3X minus 4 plus 25 cents X equals 660. Now I will tell you in the past, this is where my students make the most errors because they write sloppy and then they lose an X and then they combine the wrong terms and then they get a crazy answer that doesn't make any sense. Make sure you're being neat. You have to be neat to do math correctly. All right, so 5 cents times 3X is 15 cents X plus distribute 10 cents times 3X is 30 cents X. Even like some little mistake like that, when you go to the next step, you might think you wrote a 6 instead of a 0. Minus 4 times 10 cents is 40 cents, no X, plus 25 cents X equals 660. Now I'm going to combine all my X's. I've got 15X and 30X is 45X plus 25 cents is 65. Oh, sorry. 15X and 30X is 45X plus 25 would be 45 plus 20 is 65 plus 5 is 70 cents X minus the 40 cents, that's the constant on its own, equals 660. Now I add that 40 cents. I get 70 cents X equals $7, which makes this pretty easy to solve. Divide by 70 cents, divide by 70 cents, and X equals 10 because 10 times 0.7 would be $7. So now we know that we have 10 quarters because X alone is quarters. Then 10 times 3, so that's 30 nickels. And then 30 minus 4 is 26 dimes. Again, we don't incorporate the value at that point because we just want to find the number of each coin that the register contains. Okay, so you're going to try some problems now on your own. Again, chat with your partners, check in with me before moving on to each one to make sure that you're doing it correctly.